Welcome to the lecture series of Fourier transform. In this video I will discuss another example where you will able to determine the output of a system having the transfer function and impulse response. So basically in this question you are being asked to determine the output of the system when you are given the impulse response ht is equal to e to the power 4 ut and the input is xt is equal to e to the power minus 80 ut. So what would be the procedure as we have discussed in previous video, that you need to determine the transfer function of the system. So how could we able to determine the transfer function of the system? So if we have the impulse response, if we take it in the Fourier transform, then we will get the Fourier transfer function. So here the transfer function actually the nothing but the Fourier transform of impulse response. So taking the Fourier transform of impulse function, we will get the transfer function. And we also know that if we want to determine the output of a system, we need to multiply the input to the system with the transfer function of the system. So to determine the output of this system, we need to multiply this term with that term. So because this is the input and this is the transfer function. How could we get the transfer function? If we have the impulse response, after taking the Fourier transform, we will get the transfer function. So after multiplying that in the similar fashion, after partial factorization, we will get the value of AB, and after putting the value of AB, we need to take the inverse Fourier transform, and in this way we can determine the ut from this using these properties. If we go through the another example where we are being to determine the value of input xt, and we are given the transfer function of the system. Here we are given the transfer function and the output, but we need to determine the value of input. So what could we perform? Basically we know the if we multiply the transfer function with the input, we will get output, but in this case we are given the output and the transfer function. So first of all we need to transform these to the frequency domain, that means taking the Fourier transform of output, and after that dividing or taking these two ratio, we will get the output, because we know the transfer function is nothing but the ratio of output and input. So as we have the value of a transfer function and the output, then it would be very easier for us to determine the value of input. So taking the Laplace, tapping the Fourier transform, we get the y omega. It is very easier for us that it is very known Fourier transformation as we mentioned and we performed several times. This is the Fourier transform here, this is the Fourier transform here. So after that we finally will able to get the output of the system in frequency domain. So the ultimate goal is to determine the x omega, because in that case x omega should be determined. And how could we determine that? We actually be able to determine that by multiplying both. So when we multiply those, we actually get the x omega. So it is very easier that you can see this term is multiplied by taking the ratio actually. So when we take the ratio this and that, we will get this term, and the ultimate goal is to determine xt. However, in that case we just got the value of x omega in frequency domain, so we need to take the inverse Fourier transform of that. So how could we take the inverse Fourier transform of that? We need to transform that part by partial factorization. So after placing or after putting the proper factorization like ABCD pattern, as I have discussed in earlier where in the table you can get several format. Which format is suitable for this function you should put, and after having the constant value you need to present sort of things like that. So this is the presentation for which it is very easier for us to determine the inverse Fourier transform, because we already know 1 divided by a j omega, the inverse Fourier transform of this function is e to the power minus at. So this is a similar case. So in this fashion actually we will able to determine the xt. So this is the case. So actually this term should be delivered before that, but when I prepared this slide, actually most probably this animation has been placed after that. So I think it would be helpful, and it would be easier for you if you go through the closed loop on it. It would be very easier. So in a sense I will request you to practice more and more, and the process of having the output of a system in time domain, you need to determine either transfer function or impulse response in accordance with the input or output. When you are being asked to determine the output, you need to have the transfer function and the input. When you are being asked to determine the input, you need to have the transfer function or transfer function and the output.